guys. I hope that your quiz went well. And if you would take out your note packet, we have 2 pages to fill in, and we are working on separable equations applications. So it's going to be some word problems today. Inside this box, it says, in many applications, the rate of change, which is the derivative, of the variable y is directly proportional to the value of y. And so what does that mean? Directly proportional. You might have done that in Algebra 2, but something that is directly proportional would say the rate of change, dy dt, is directly proportional to y. So that means k, which is a constant, times y. So just labeling things, the dy dt is our rate of change of y. Is my equal sign, and directly proportional means k times y. K is also referred to as the growth rate. So let's just take this first one, and it says solve the differential equation. You should have done this on your quiz. We're going to separate and integrate. So to separate, I am going to divide both sides by y. So 1 over y dy. On the right side, I'm going to keep the k. It's just a constant. And I'm going to bring dt over there. So now I'm putting y's on one side, t's on the other side. Keep in mind that k is a constant. It's just a number when I integrate. So now and I've separated, now I'm going to integrate. So on the left-hand side, the antiderivative of 1 over y is the natural log of the absolute value of y. Over on the right side, the antiderivative of k with respect to t is kt plus c. And then in order to solve for y, I'm going to make e the base of both sides. Over on the left, e raised to the natural log crosses off. The absolute value goes away. And I have y equals e raised to the kt plus c. And this is a problem that would require a c wrap because the plus c is up in the exponent. We are going to wrap it around to the front. And my equation is going to be y equals ce to the kt. Okay, this might look familiar from Algebra 2 and pre-calc. You guys did a lot of equations with growth and decay that said y equals ce to the RT, or maybe PE to the RT. Your teacher might have said PERT. It's the same thing. We're just using different variables. Something to note is that if you ever have a differential equation that looks like this, when you solve it, it will always turn into this. So what I mean by that is, for example, if you had dy dt equals 5y, you could separate and integrate, or you can know that it's going to turn into this. When you separate and integrate, it's going to turn into that exponential equation there. It's going to be y equals ce, and k is 5, so to the 5t. So these will always turn into ce to the kt. All right, so exponential and growth and decay models. It says if y is a differentiable function of t such that y is greater than 0, and if dy dt equals ky, that's the same equation that I just circled, it will always turn into y equals ce to the kt. Important things to make note of. C is the initial value. K is the proportionality constant. Oftentimes we have to solve for k. And also, if it's exponential growth, the constant is greater than 0. Exponential decay, the constant is less than 0. So let's jump down and start problem 1. This is taking it way back, 1993, AP Calculus exam AB number 42. And it says, a puppy weighs 2 pounds at birth. So something I might write down for that is at time equals 0, this puppy weighed 2 pounds. So 2 pounds was its initial weight. Okay, then it says, and it weighed 3.5 pounds 2 months later. Small dog. So at time is 2 months later, it weighed 3.5 pounds. If the weight of the puppy during its first 6 months is increasing at a rate proportional to its weight. As soon as I see wording like this, I'm thinking we're talking about exponential growth. Okay, when they start talking about proportionality. So as soon as I see that, I know that I'm going to be using this equation, y equals CE to the KT. And the question reads, then, how much will the puppy weigh when it is 3 months old? So I want to know when time equals 3, how many pounds do we weigh? That's what we're looking for. All right, so let's plug in some things that we know. I know that my initial weight is 2 pounds. So C is the initial. So I can put 2 in for the initial weight. Then I can use this right here. I know that when time is 2, this puppy weighed 3.5 pounds. So I'm going to put in 3.5 pounds for Y. And in for time, I'm going to put in 2. And then I'm going to solve for K. And in lots of the problems, you're going to have to solve for K before you can do anything else. So I'm going to divide both sides by 2. To get rid of the E, I need to take the natural log of both sides. And then I need to divide both sides by 2. So K equals the natural log of 3.5, all divided by 2. I'm sorry, it's the natural log of 3.5 over 2, all divided by 2, like that. I'm going to type that into my calculator. I'd like for you to do the same. I can make a fraction bar, typing in the natural log of 3.5 over 2, and I'm dividing it by 2. And I get that K is 0.279807 ... It's a long value, but it's important to know what K is. Okay, then I'm going to come back to my equation. My equation was Y equals CE to the KT. And remember, what we're looking for is how many pounds did it weigh at time is 3? So I'm going to go into this equation and say, how many pounds did we weigh? Our initial weight is still 2. Our K value is 0.279. And I want to know at time is 3. Now, something I will say about this K value, I would store this in my calculator. I'll store it as A, just because A is so easy to get to. So into my calculator, I am typing in 2 times E raised to the A, because I have that stored as A, times 3. And I get Y equals 4.630, and that's pounds, was how much this puppy weighed at 3 months. So we have a small little puppy. And this would match up with B. Okay, let's flip our paper over. And on the back, we are going to go in a little bit of a different order as we go through. Okay, so on the back, we're going to start on number 4. This is an actual question from way back when, 1998. And if we read it, it says, population Y grows according to this equation. So as soon as I see this equation, I can either separate and integrate, or I can remember that when I separate and integrate, I get Y equals CE to the KT. This is direct proportions, where K is a constant and T is measured in years. So something I know is that the population doubles every 10 years. And I want to know what is the value of K. That's what we're looking for. So if the doesn't tell us what we start with, but I know that the population doubles. So let's say I started with 100, I would have 200. I started with 3, I would have 6. It doesn't matter what we start with. I just know that I double. And so the easiest thing to start with would be the number 1, because when I double it, I get 2. E to the K is what I'm looking for, and it takes 10 years to double. So in for time, I'm going to put 10. The problem's asking me to solve for K, so I'm going to take the natural log of both sides. So I'm going to say the natural log of 2 equals 10K, and I'm going to divide both sides by 10. So K equals the natural log of 2, all divided by 10. If I type that into my calculator, make sure you close parentheses after the 2, I get 0.0693, and that would be A. Okay. All right, let's work our way up. You can pause the video at any time if something doesn't make sense. Let's look at number 3 next. So number 3 says if dy dt equals negative 2y. So I want you to compare for a minute. Compare this and this. They look really similar, right? Except for instead of k, it actually is a negative 2. So when I see that, I could separate and integrate, or because we're on limited time on our AP exam, we could remember that this is going to be y equals ce to the k, which is negative 2, t. And that's the equation that I'm going to be using for number 3. Again, you could have separated and integrated, but we don't need to. Then it says if y equals 1 when t equals 0. So I could plug that in, or when time is 0, that's going to be my initial. I could also plug it in and solve for c. I would get c as 1. But my initial is going to be 1. So I'm going to plug in here. I'm going to plug in 1 for c. And it says, what is the value of t for which y equals 1/2? So let's put 1/2 in here. E to the negative 2t. I need to solve for t, so I'm going to take the natural log of both sides. So on the left, the natural log of 1/2. On the right, the natural log and the e will cross off, and I have negative 2t. So if I divide both sides by negative 2, I get t equals the natural log of 1/2 divided by negative 2. Now, unfortunately, there's no answer. This is right, but there's no multiple choice answer that looks like that. So when I'm glancing through my multiple choice answers, I notice that some of them have a 1/2 in the front of the word natural log. So what about if we rewrite this as t equals negative 1/2 natural log of 1/2. Just rewrote it. So it's not going to be A, because A says negative 1/2 natural log of 2. So we can cross that off. Then I'm going to use, it looks awfully similar to this with the 1/2 in the front. But what I have to do is I have to use my log rules. If ever you have any coefficient of a log, you can rewrite it as an exponent. So I technically could take the whole negative 1/2 and put it up there, but because I'm looking at my multiple choice answers, I'm just going to take, and trying to match it, I'm just going to take the negative 1 and put it up there. So I have t equals 1/2 times the natural log of 1/2 to the negative 1. Now we know that anything to the 1/2 power, anything to the negative power can be flipped. So if it's raised to the negative 1, it just becomes 2 to the positive 1. And now that looks like that. In that one, the simplifying, in my opinion, was what was pretty difficult. Okay, now we'll go up to problem number 1. Actually, it's problem 2, but at the top of the page. And it says, suppose that an experimental population of fruit flies increases according to the law of exponential growth. So if you're on your AP exam and you see them talk about exponential growth or even exponential decay, this is the formula that we're going to use. Y equals CE to the KT. They tell me that there were 100 flies on the second day. So at time equals 2, we had 100 flies. And 300 flies on the 4th day. So when time is 4, 300 flies. How many flies were in the original population? So I need to solve for C. I need to find C, which is my initial condition, or my original population. So I'm going to see what we can do. If I go into this equation, and let's say that I use the time is 2, 1. I would plug in 100. I'm plugging in this stuff. 100 equals CE to the K times 2. Okay, still have 2 variables there. What if I took my original equation, and what if I plugged in the other one? What if I plugged in this bottom one now? 300 flies equals CE to the K times 4. What I can do is I can pair both of these equations up, and I can solve them for C. And then I can go back and I can figure out what C is. So if I take this equation and the one on the left and I solve it for C, it would be 100 over e to the 2k equals C. And over here on the right, it would be 300 over e to the 4k equals C. All right, one thing I notice is that both of these things are C. This is C and this is C. So what would happen if we set them equal to each other? If they're both C, then they should be equal to each other. So I'm going to say 100 over e to the 2k equals 300 over e to the 4k. And I need to solve this for k. So I need to get my k's on the same side. So doing some algebra, I could basically switch places with these two terms, because I could divide both sides by 300 and I could multiply both sides by e to the 2k. So it's going to look like this when I simplify. 100 divided by 300 equals e to the 2k over e to the 4k. And our goal is to solve for k right now, and then we'll go back and figure out what c is. So if I simplify, this left-hand side is 1/3. On the right side, I'm dividing two things with the same base. The base is e. I can keep the base and subtract the exponents. And 2k minus 4k is negative 2k. Take the natural log of both sides. And finally, divide both sides by negative 2. Okay, so now I'm going to go into my calculator, and I'm going to type in the natural log of 1/3, closing my parentheses, divided by negative 2. And I get that my k value is about 0.549. I'm going to store it in my calculator as A, just so that I have it for later. Now, the problem really asked to find C. So if it asked me to find C, I can go back to either of these two equations and find C. It doesn't matter which one. I can go back in and say 300 divided by e to the 4 times 0.549. So 300 divided by e raised to the 4, and I I stored it as A. So E raised to the 4A. And I get C is 33.333. Ran out of room here. 33.333. And it was not multiple choice. Okay, we've got one last problem that we're going to get through. And it's down at the bottom. It's from 1993. It was a BC Calc exam, but we can still do it. And they're talking about a pandemic, so this should sound familiar. It says, during a certain pandemic, the number of people that are infected at any time increases at a rate proportional. All of a sudden, I start seeing this word proportional. At a rate proportional to the number of people that are infected. I see proportional. I immediately am going to write down y equals CE to the KT. Okay. It says, if 1,000 people are infected when the epidemic is first discovered. So I could write down at time is 0, 1,000 people are infected. 1,000 people are infected. Or I could write down that C is 1,000. That's how much we start with. Then it says 1,200 people are infected 7 days later. So at time is 7, 1,200 people are infected. How many people are infected? These are people. How many people are infected 12 days after the epidemic is first discovered? So after 12 days, how many people? And that's what we're looking for. So let's use our equation. Our equation is y equals CE to the KT. And let's plug in things that we know. Well, we know that the initial amount is 1,000. That can go in for C. E. And I don't know what K is. I'm looking for K, but I can use this condition here that at time is 7, so K times 7, I have 1,200 people infected. Okay, so now I'm going to try to solve this for E. So I can divide both sides by 1,000, and then I'm going to have 1.2 equals E to the 7K. We have to solve for K, so let's ln both sides. ln of 1.2 equals 7K. And K is going to equal the natural log of 1.2 divided by 7. And I'm going to type that into my calculator and get a decimal. I get that K is 0.026. And I'm going to store it as A so that I have it for later. Okay, not done with the problem. Problem asks, after 12 days, how many people are infected? So let's go back to our equation. And I want to know how many people, so I'm looking for Y. I know I started with 1,000, E. I know that K is 0.026, which I'll use the exact value in my calculator. And I want to know after 12 days. So let's type it in. 1,000 times E raised to the, I have it stored as A times 12. And after just 12 days, 1,366 the decimal I'm getting is 908. And so when I look at my multiple choice answers of how many people are infected, it's 1,367 people. Okay, great job, guys. I will grade your quizzes this weekend. If you feel like you want extra practice on these type of problems that I just did on the quiz review, totally optional. But on the quiz review, the two that we skipped, which are number 4 and number 5, those are on decay, growth and decay. So you're welcome to try those. You don't need to. Remember, you have 3 things due on Monday. Everything is listed in Schoology. Great job, guys.